Next topic we're going to look at is scientific notation. Now, scientific notation is also known as standard form. This is simply two different names for the same thing. Standard form then is a way that we have of writing either very large or very small numbers using the fact that they are something to the power of 10. It's used a lot in science for things like the very large values, like the distance between the Earth and the Sun, or very small values like the radius of a hydrogen atom. Okay, so writing numbers in standard form of scientific notation then. To write a number into standard form of scientific notation, it must be in the form a times 10 to the power of n. That means it must be written as a number or integer, which just means any number without a decimal point. So it's a number times 10 to the power of something. If this number here is positive, it's a big number. If it's negative, it's a small number. The only other thing we need to remember is this number at the beginning must be between 1 and 10. So it can be 1, but it can't be 10. It needs to be a single digit. So we can go up to 9.99999, but there needs to be a single digit before the point. Otherwise, you could take another multiple of 10 away. If we're thinking about multiplying by 10, if we do 10 times 10, which is 100, we've done 10 squared. Remember, doing 10 squared means 10 times by itself. If we extend that, if we do 10 times 10 times 10, we get 1,000, but we can also write that as 10 to the power of 3. Similarly, we can go up to 10,000, which is 10 to the power of 4, and every time we add on another times 10, we simply add an extra number onto our power. Let's see how this helps us then. Okay, if we've got 8,370, I'm going to do this one out in full, we'll then look at a short way of doing the rest, just to make sure we understand this first one. Then I have got 8,370 times 10. So if I times by 10, I get my 8,370 back. If I take it down one more, I get 83.7 times 10 times 10. And down one more decimal place, I get 8.37 times 10 times 10 times 10. If I shorten that, times 10 times 10 times 10 is times 10 to the power of 3. Okay. The bottom one there, is it written in standard form? Good news is we don't need to go through these steps every single time, because we should be able to see what's happening when we're timesing by 10. Okay, so I'm going to go back, show you a quicker way of doing it now. That's really what we are doing each time, but we don't need to write in all this work in each time. Okay. If you times or divide by 10, move your decimal point one space. So if we look at our number here, right now, I've got a decimal point here at the end. Every number has an invisible decimal point. I want my decimal point to end up between the 8 and the 3, because I only want one number at the beginning, so my starting number is between 1 and 10. So move back 1, 2, 3. My decimal point goes in there, and I've moved it 1, 2, 3 spaces. So I get 8.37 times 10 to the power of 3. No need to put the 0 on at the end. Second one, my number is going to be just 9. So it's going to be 9 times 10 to the power of something, and then we count 1, 2, 3, 4, 5, 6. So I get 9 times 10 to the power of 6. Next again, we've got 67.0000. Again, my number is going to be 6.7. So I need my decimal point to end up in there. So I've times it by 10. 1, 2, 3, 4, 5 times. So I get times 10 to the power of 5. 48, my number is going to be 4.8 at the beginning, so I've times by 10 just once. You can put a 1 in, you don't need it in. Okay, it's not wrong with it, but we don't need it. We don't usually put powers of 1 in. E, I've got 3,219, doesn't matter, there's no zeros in this one. We can still think about it the same way. So we've moved our decimal point 1, 2, 3 spaces. So we get 3.219 times 10 to the power of 3. And the last one, we've got 56,003. My aim is to get my decimal point here. So we've got 5.6003 times 10 to the power of, and times by 10, 1, 2, 3, 4 times to get back to where we started. So it'll be times 10 to the power of 4. We can do this the other way as well. We can write these numbers back in full. We've got 5.6 times 10 to the power of 3. Again, I'll do this one out full for you. That means 5.6 times 10 times 10 times 10. Now 5.6 times 10 would be 56. That's been times by 10 once. That's my decimal point. Times by 10 again, add a 0. Times by 10 again, add a second 0. Okay. Again, we don't need to do all that working. We should just be able to work this out. Okay, I always find this way slightly easier, writing it back into normal form than I'm writing it into standard form. What I do is I say, right, okay, I need to times by 10 once to get rid of my decimal point. So that gives me 56. I had 3 chances to move my decimal point. I've got 2 left, so I add them in with zeros. Next one, 7.43 times 10 to the power of 6. Here, 1, 2 spaces to get rid of my decimal point, and that gives me 743. I've used up 2, I had 6, so add in my 4 zeros. C, 2.07 times 10 to the power of 2. I use up 2, getting rid of my decimal point. None left, so I don't need to add anything on at the end. D, 5.47 times 10 to the 5. 1, 2 to get rid of my decimal point. I've got 3 left. Add in my 3 zeros. 9 times 10 to the power of 1 would just be 90. No decimal point. I've got 1 10 to times by, so add on a 0. F, I've got 2.13 times 10 to the power of 2. If I times by 10 twice, it ends up in here, so I don't get rid of my decimal point this time. So I get 213.4. Okay, let's have a look at small numbers then. Small numbers, it's very similar. Instead of timesing by 10, you can think of it as dividing by 10. What we're really doing is timesing by a tenth. And a way of writing a tenth is 10 to the power of minus 1. So when we're writing small numbers in standard form, instead of doing it to a positive number, we do it to a negative number. Apart from that, it's the same idea. You're still looking for what your starting number is. You're still looking for how many spaces you've moved that decimal point. So in this first one, if you've got 0.009, my number that I've got between 1 and 10 there is 9. So I have moved my decimal point from here to here. So I have moved it back 1, 2, 3 spaces. So I get 9 times 10 to the power of negative 3. This one, my number between 1 and 10 is going to be 2. I've moved my decimal point from here to here, so I've moved it back 1 space. 8 times 10 to the power of negative 1. In this case, we must have the 1 in because of the negative sign. Doesn't matter so much with positive, does with the negative. Okay, next one, we've got 0.498. Your number between 1 and 10 here is going to put your decimal point in here. So we get 4.98. I've moved my decimal point one space, so it's times 10 to the power of minus 1. What you might start to notice with, and it only works with the small numbers, see however many zeros you've got, that's going to be your power. See, we had 3 zeros minus 3, 1 0 minus 1, and it works every single time. It doesn't matter about the fact the ones before the point, it's just the number of zeros that we're looking at. Our number here then is 5.4. Let's count. We've gone from here, we've gone 1, 2, 3, 4, 5, 6, 7, 8 spaces. So that'd be times 10 to the power of negative 8. Do double check my counting. 1, 2, 3, 4, 5, 6, 7, 8 zeros. Okay, next one, my number's going to be 5.06. Oh, getting ahead of myself here. 5.06, that's better. Times 10 to the power of negative 1, 2, 3, 4. Okay, zeros, 1, 2, 3, 4. Numbers going to, decimal point is going to go in here. So 8.6321 times 10 to the power of negative 1, 2, 3. And the zeros, 1, 2, 3. Okay. Let's see if we can do the opposite then and rewrite numbers from standard form back into normal form. So this time we've got 4.1 times 10 to the power of negative 3. What we're really doing here is taking this decimal point and we're moving it back 3 spaces. So we're going 1, 2, 3. There's my new decimal point. I fill in all my spaces with zeros and I get rid of that decimal point there. So I get 0.0041. It gets a wee bit clumsy doing it that way, especially if you have a large amount of numbers. Like if it was times 10 to the power of negative 8. It's really easy to miss one as you're counting back. What I prefer to do with these ones is use the fact that when it's negative numbers, the number of zeros matches the number of the power. So if I'm looking at 4.1 times 10 to the power of negative 3, I know that means I've got 3 zeros. Now it's 3 zeros in total. So I've got 0.00 and then my number is just going to be 41. And then I find it easier to check it the other way around. I've moved that decimal point 1, 2, 3 spaces to get back to my 4.1. Make sure you don't leave a decimal point in there though. Every number should just have one decimal point at most. B, times 10 to the power of negative 5. That's going to be 0.0000. It's 5 zeros, 872. Again, no decimal point left in the number now. It's been put in here at the beginning. Negative 2, so I want 2 zeros altogether, and then my number without the decimal point. 5.312 times 10 to negative 5, 5 zeros, and then my number without the decimal point. 8 times 10 to negative 2 would be 0.08, and again you can always do a wee check. Let's move the point 1, 2 spaces. Last one, times 10 to negative 4, so we get 0.000, and then I need that full number in there, so 70909. Okay. I'll leave you to practice these and then we'll have a look at scientific notation in calculations.